All right, so yesterday we looked at GCF and some of the special cases, sum and difference of cubes and difference of squares. Remember, there's no sum of squares. We're going to look at some that we're going to factor that have 3 terms, some that have 4 terms, some more that have 2 terms. Even if you're good at this factoring, I might say something that might help you make it even easier for yourself, or maybe you're not really good at this, but we need to get really good at it. So if you look at 15 and 16, they are set up both like quadratics, and I say like quadratics because this 16 isn't really a quadratic. And the exponents are ordered greatest to least. And in both cases, a is 1. And what I mean by a is this. We have ax squared plus bx plus c. That's your standard form of a quadratic. And so if a is 1, we have a little bit of an easier, different factoring technique than if a is not 1, right? So when I look at 15, a is 1. There's no number in front of here, so that's great news. That means I can jump to 2 binomials here. And then that's m squared. So this is m and this is m. Now, before I worry about any numbers at all, I'm going to worry about signs. I look at the last term. It's negative. Since 30 is negative, that means the signs inside the parentheses are opposite. That helps. Then I'm looking for 2 numbers that multiply to give me 30 and combine to give me negative 13. What do we think? 3 and 10 sound great, but are we going to add or subtract the 3 and 10? Look at the signs. They're opposite, right? So 6 and 5, if I subtract those, will I get 13? 15 and 2, right? And I did this one in particular because if this ever comes up, 90% of y'all would have 10 and 3 because you'd throw it down. You wouldn't even bother to check anything. You're like, well, 10 and 3 is 13. But since the signs are opposite, they have to subtract. So it would have to be 15 and 2. And then since the signs are opposite, since this number is negative, then my bigger number is negative. So the 15 would have to go here and the 2 would have to go there. So after you factor, even the simple ones to factor, double check yourself. So I know that 2 times negative 15, okay, that's 30. But then I have a positive 2 times m and a negative 15 times m. When I combine those, that's where I get my negative 13, okay? So just be careful. Even if you feel like you get the numbers real quick, you might, but there might be one that's kind of a trap like that one. We're good? All right, so number 16, that is not a quadratic. It's a 4th degree or a quartic, but it's set up like a quadratic. So I can factor it the same way. It does not make it any more difficult. As long as if this is x to the 4th or whatever that is, that this exponent is half of that one, then we're good, and so it works. So I can, a is still 1, I can jump to this right here. And since that is x to the 4th, then I would have x squared and x squared here. The 20 is negative, so the signs are opposite. And 2 numbers that multiply to give me 20 combine to give me, or subtract to give me a negative 1. 5 and 4. And since this is negative, the bigger number is negative, so this is a 5, this is a 4. Now, because I still have x squareds there, I need to check to see if I can factor it anymore. Can I continue to factor this one? No, because that's a sum of squares, right? There is no rule for sum of squares, so I can't do anything with it. This is a difference, but is this a difference of squares? No, it's not a perfect square, so I cannot factor anymore as we go through. Okay, everybody good with that? All right, so now on 17, a is not 1. When a is not 1, or even if a is 1, what we should have even checked on that is check for a GCF. Can I factor a GCF out of 17? No, right? Which makes me sad because I was hoping I could factor out that too. So I cannot factor out a GCF. There are different ways that you could have been taught to factor this, and y'all had many different Algebra 1 teachers, I'm sure, and Algebra 2 teachers. But I don't care how you do it if you know how to do it and know how to do it right. I've retaught it multiple different ways over the years, depending on what the current trend is and how they're teaching it. And I think for the most part, everybody's learning grouping. If you have a different way with a box or whatever and you know how to do it, knock yourself out. Don't ask me about the boxes because they don't make any sense to me and I think they're ridiculous. But if that makes sense to you, that's fine. I don't care. But if you don't really have anything to latch onto, this is what you need to latch onto because it applies to other things as well. So we're going to take this 2 and we're going to multiply it by -7 and we get -14. So now I need two numbers that multiply to give me -14, which means the signs will be opposite, and they need to combine or subtract basically to give me a -13. So what do we think those two numbers would be? 14 and 1. Good. So I'm going to rewrite this 2d squared. Basically what I'm doing here is splitting this term. So I can have a -14d plus d minus 7. When you get to that step and you have split that middle term, make sure that these two things, when you put them back together, that you will get that back right there. Because if you don't, then you might have your signs backwards or the wrong signs altogether or whatever. Everybody good with so far? Somebody knocking. Not so lightly, it's hard. Oh. All right, so then I'm factoring by grouping. So I'm going to group these two together. What can I factor out of this? 2d. That leaves me with d minus 7. Now, out of these two, technically there's nothing I can factor out, right? And I can factor out a 1, but that seems ridiculous when we're just doing normal GCF. But in this case, you have to factor out something. So if all I can factor out is a 1, and it's a positive 1, so I do +1, and then I'm left with d minus 7. Okay. Everybody with me so far? So then I've got this 2d plus 1 that I'm going to make into a little binomial. And then I have this d minus 7. I have to make sure that what's in my parentheses matches. If they don't match, then either I did something wrong or it's not going to factor. And then this is d minus 7. And then we are completely factored. Okay. Any questions? We good? We're just knocking some cobwebs off maybe? All right. On 18, is there a GCF that I can factor out? No. And this is also a quartic, but I have q to the 4th and q squared, so it's set up like a quadratic, so I can treat it like a quadratic. That means that I'm going to take this 4 and multiply it by 9 and get 36. Since that is positive, this 9 is positive, that means the signs will be the same. It's either plus, plus, or minus, minus. Since this is negative, that means my signs are minus, minus. Okay, that helps me there. So I need two numbers that are going to multiply to give me 36 and add to give me 13. 4 and 9. All right. So I'm going to get 4q to the 4th minus 9q squared minus 4q squared plus 9. Now, I think whoever said that said 4 and 9, and I put 9 and 4. It doesn't matter either way. I don't know why I put 9 first. It really doesn't matter. Any questions on where we got anything or why I'm doing anything I'm doing? All right. So now we group. Out of these first two, what can I factor out? Q squared. Good. Q squared, that leaves me with 4q squared minus 9. Then what can I factor out of the next two? If this term, if the first term in the second group is negative, you have to factor out the negative, okay? And there really isn't anything else they have in common except a -1. So I'm going to factor out a -1. When I do that, that negative 4q squared becomes positive 4q squared, and that plus 9 becomes minus 9. And then I can see that my parentheses match, so I'm good to move on. I make these into a binomial, so I'm going to get q squared minus 1 times 4q squared minus 9. Everybody with me so far? Now, can I factor this one more? Is this a difference of squares? It is, right? Q squared is a perfect square, and so is 1. So this right here is going to become q plus 1 times q minus 1. Is this a difference of squares? Yes, they're both perfect squares, right? So that can become 2q plus 3 and 2q minus 3. What questions do we have? Anything? No, we're good? All right. Now, when we look at 21, and I know the numbering doesn't make sense. A lot of times the numbering won't make sense. Don't focus on that. This has 4 terms, which for some of your little brains, you're going to be like, that's got to be more difficult. But this one only had 3 terms. This one's actually easier. Notice we took the 3 terms here, we split that, made it into 4 terms. Then when we got here, we were able to do the grouping. Well, basically, they've already split it for me, so I get to skip that whole first step before I have to make all those decisions. So as long as I have them, I mean, it helps to have them in a descending order of your exponents. That's how it is. So I just start by grouping. I'm going to group those 2 together. What can I factor out of that? H squared. That leaves me with 2h minus 3. And then out of these 2, what can I factor out? 3. So positive 3. And that leaves me with 2h minus 3. Remember, if your parentheses don't match, you either made a mistake or it's not going to factor. Okay? And on this assignment, it's because you made a mistake, because everything I gave you will factor. So now I set this up as h squared plus 3 times 2h minus 3. Can I factor this anymore? No. Can't do anything else with it. Everybody good? Any questions at all? All right. On 22, my variables disappeared. Sometimes random things disappear when I move things around. I don't catch it, and I don't know where they go or what happens. So let's just put x's in there. X cubed plus 7x squared minus 5x. All right, so we're going to go ahead and start by grouping. So out of the first 2, what can I factor out? X squared. Good. That leaves me with x plus 7. What can I factor out of the next 2? Negative 5. Very good. And that also gives me x plus 7. So that's good, right? So now I get x squared minus 5 times x plus 7. Can I factor this anymore? No. That is a difference, but it's not a difference of perfect squares. So, any questions at all? All right, now besides the degree of the polynomial and the numbers and how many terms and stuff there are, what's the main difference between 21 and 25? Equals 0, right? This is an equation. This is not. So far, all we've been able to do is factor. There's been no solving. And so you have to understand what directions mean when they say things. So if you had done all this, and then you kept going and put 2h minus 3 equals 0, and then you get h equals 3/2, you're totally wrong, because you can't solve it because it's not even an equation. So you got to know when to stop and when to go farther, right? Just because it's an equation, maybe the directions are just factor it. But if it's to solve it, then we got to know what that means as well. So if you're going to factor to solve any sort of quadratic, or really any equation that's not just a linear, then we want it set equal to 0. This is set equal to 0. We're good. Can we factor out a GCF? Yes. What would that be? 5n. So I'm going to factor out a 5n. That leaves me with n to the 4th minus what? It's 16. You don't have to stare at it and do it in your head. If you need to do a little division off to the side, that's totally fine. Okay. All right, now, can I factor this more? Yes. What I can't do is drop this guy off. He's along for the ride, right? But this is a difference of squares, right? I can take the square root of both. So this gives me n squared plus 4 times n squared minus 4. And all that equals 0. We can't drop that off either. You rewrite everything. You don't just have random stuff scratched all over the place. Can I factor some more? Yes. This guy's still along for the ride. Can I factor this anymore? No. So then he's along for the ride too. N squared plus 4. And then this is a difference of squares. So that's going to give me n plus 2 times n minus 2 equals 0. Can I factor anything anymore? It's fully factored, right? Natalie asked me a question. I can tell by the look on your face. Either you can't see or I lost you somewhere. I just can't see. Okay, you're fine. Just want to make sure I didn't lose everybody's good. And because I know even when you're paying full attention, sometimes it's just you look down, then you look back up, and you're like, I don't even know what just happened. Are we good though? Everybody with me? Okay. So it is fully factored. Now I need to solve it, which means you take each little term. So I'm going to take this 5n, and I'm going to set it equal to 0. If 5n equals 0, then n equals what? 0. Divide both sides by 5, right? Then I got to take this, n squared plus 4, set that equal to 0. So n squared equals negative 4. How do we undo a square? Square root. And if you introduce the square root when you are solving, what do you have to put so you stay out of math jail? Plus or minus. Plus or minus, right? Because you get two answers. The square root of 4 is 2, but because it's negative, what do I also have to put on it? I. Imaginary number, right? So we've done this one, we've done this one. Got to do this. I know there's not a lot of room, sorry. I redid it so we'd have more room, but I took off the extra room I had to actually do that, so whatever. Nothing I ever do is going to be 100% perfect. I've finally decided. Oops, I can't even talk, and I can't talk and write. I set that equal to 0, so I get n equals negative 2. Then I set this last one equal to 0, n minus 2 equals 0, so n equals 2. What questions do we have? Anything? Okay, that's your 0 product property. That's what you're using when you solve. All right, what do you think the first thing we need to do in 26 is? Set it equal to 0, absolutely. Would you like to move everything to the left or to the right? To the right. Now, there's not a correct answer. You can do either one. You just have to deal with a negative. You always want your leading term to be positive, so we could factor out a -1, but I think it's really better just to move it to the other side. So let's move everything over to the right. So that means I'll start with 0. 0 equals 6k squared plus 14k plus 4. Now, can I factor out a GCF? I can. What's my GCF? 2. So I'll get 0 equals 2 times 3k squared plus 7k plus 2. All right, now, just as an FYI, if I had not factored out my GCF, because sometimes y'all blow right past that, and I could have multiplied the 6 times the 4, got 24, look for factors. I could still do all that and get the right answers in the end. The problem is my numbers get bigger and then things just get more complicated. So it's actually simpler to do it at the beginning. All right, so now we're just worried about what's in the inside. I really wish I'd have factored the whole 6 out and been able to say that A is 1, but I didn't do that. So I need to multiply the 3 times the 2. That gives me 6. Now remember, this stuff is still along for the ride. That 2, he's hanging out there. I need 2 numbers that multiply to give me 6, combine to give me 7. 6 and 1. So inside here, I'll have 3k squared plus 6k plus k plus 2. The next step requires me to add more parentheses. So the parentheses I have right here, I'm going to turn into brackets, and you'll see when I do it how it just makes things look better so you don't get lost in your own stuff. But basically, I'm going to do grouping with what's inside the parentheses, but I can't lose the 2 and stuff out there. So I get 0 equals 2, and I got these brackets. Out of those first 2 terms, what can I factor out? 3k, and then that's going to leave me with k plus 2, right? Out of these 2, what am I going to factor out? A 1, which seems weird, but you have to, and it's a positive one, so don't forget your pluses and minuses, because sometimes y'all leave those off, and then you start to confuse yourself, and then you make up math. And then this is k plus 2. But do you see how making that first set of parentheses into brackets doesn't make it just like a whole lot of parentheses that make your brain hurt? So now I can drop the brackets, and I get 0 equals 2 times 3k plus 1 times k plus 2. Everybody with me so far? Am I finished? No, because I need to solve, right? Now, all these little equals things that I set up, you don't necessarily have to write all of those. That's okay, but we all may be kind of at different spots with that. Some of you may feel like, you know what, I need to keep doing it so I don't do anything ridiculous. Some people write it all the time because they write all their work and everything they do. If you're skipping steps, that's okay as long as you're not making mistakes, because skipping steps is what usually leads to just careless mistakes. So I don't have to necessarily write it all out, but if I do this 3k plus 1 equals 0, especially if you have a number there, it's probably better so you get the negatives correct, you don't get your fractions upside down, and you can see that k would equal, I'd subtract that over, -1/3. And then, so I took care of this, right? And then this will just give me a -2. Is this guy going to give me a 0? No. This guy did, but that's because it had he had a variable on him. That's why I got this. But this is just a coefficient. If I dropped that 2 off somewhere, it wouldn't change my answers right here. But if I was graphing this and had to do something with that, it would totally affect that. It affects the stretch. It just doesn't affect where it crosses the axis, okay? So we just don't want to ever drop anything off. What questions you got? All right. 28, what do you think we need to do first? Set it equal to 0. You want to move everything to the left or to the right? Yeah, I think I'd move it to the right because I want my n squared positive. But again, you can always factor out a -1. So it's going to give me 0 equals 6n squared plus 8n. And then before you start doing weird things like square roots, because I promise you I'd see that from somebody on here because you got a square. No, no, no. We're going to try and factor. Can I factor out a GCF? Yes. 2 what? 2n. Good. So I've got 2n. That leaves me with 3n plus 4. And it's completely factored, right? I'm done factoring. This was not nearly as complicated as it may have looked from the beginning. This 2n, what's this going to give me? 0. And this would give me what? Earlier today, I heard somebody said -3/4. And I go, you sure? Yeah, I'm sure. Okay, well, this is why we write it down. 3n plus 4 equals 0. It's going to be 3n equals -4. N equals -4/3. So not writing at least some of it down is what, again, leads to the careless mistakes. And so this is -4/3. Ask me questions. Are we good? Yes, yes. It's okay if you're not. You just have to tell me. All right, let's look at 29. You want to move everything to the left or to the right? Yeah, I think we'd go to the left. So that means I'm going to subtract this. So I'll get 2x squared minus 8x minus 42 equals 0. Now, could I, not necessarily is it the best thing to do, but could I make my next step 2 times -42 to get that 84? I could. But 84 is a big number. Can y'all rattle off the factors of 84 to me right now? Some of you maybe, some of you no, or you could, but you really don't want to. That's fine too. That's the team you're on. But I don't have to because I can factor out a GCF, right? My GCF is 2, so I'll factor him out, and I get x squared minus 4x minus 21 equals 0. And then the really great news is now A is 1. I don't have to do the grouping stuff at all. Okay, it's because I recognized that I had a GCF. So that means I can jump right to having the 2 sets of parentheses. I have x and x. 21 is negative, so the signs are opposite. And then I need 2 numbers that multiply to give me 21 and subtract to give me negative 4. 7 and 3. Good. And which one is negative? The 7. So 7 here and 3 here. And somebody did ask me earlier, well, could I have made it plus 7 and minus 3? Well, not and be correct. If I did that, I'd still multiply and get 21, but it then would have given me a positive 4. So the signs matter. And then I would think that a lot of you probably don't need to write down the little stuff there. That's just going to give me a negative 3 and a 7. Okay. Any questions at all? All right. One more. Can I solve number 30? No, why not? It's not an equation, right? It's not equal to anything. It's not an equation, so I can't solve it. It's supposed to be an equation. The equals 0 disappeared along with my variables from up there, but it was a good talking point, so let's put it equals 0 there. You don't get to willy-nilly do that, only because I told you that's really what it's supposed to be. All right, do I have a GCF here? Yes, that's good. So I don't have to multiply 6 times 24. So 6 times z to the 4th minus 5z squared plus 4 equals 0. Now this is a 4th degree. We don't need to freak out or make up math or skip it or anything else like that. We can treat it like a quadratic. So this 6, he's still hanging out here. And a is 1, so I can skip to the double parentheses here. Since that is z to the 4th, this has to be z squared and z squared. The 4 is positive, so the 2 signs inside are the same. They have negative, negative, or positive, positive. Since this is negative, I know that it's negative, negative. Okay. Then I need 2 numbers that multiply to give me 4, add to give me 5. 1 and 4. There we go. Can I factor this more? Yes. So this 6 is still hanging out here. This z squared minus 1, is this a difference of squares? Are they both perfect squares? Yes. So this is z plus 1 times z minus 1. And then is this a difference of squares? Yes. So then this is z plus 2, z, oops, that looks like a 21, hang on. 2z minus 2 equals 0. So I have a total of 4 zeros here. The 6 just is hanging out there. He doesn't give me a 0, right? You can write this a couple of different ways. You can list out all 4, and that's totally fine. Or you could do something like this. Z equals plus or minus 1 and plus or minus 2. Okay. Or you could list out all 4 either way. But I just want to make sure you know you can see it both ways as well. What questions do we have? Anything? All right. Then your assignment is in Delta Math.